Hi, so today I hope you attempted to do this before you look at this video, so please try to do it on your own first. So today we're looking at an isosceles right triangle and the legs have a length of 1. The first question is asking what is the measure of the other two angles. So they're asking for this angle and this angle. Well, what we do have right now is this 90-degree angle. So that means that the two angles have to add up to 90. And what we know is if you have the same side, the opposite angles will be the same. So that means that both angles have to be 45 degrees. And so now the next question is using Pythagorean theorem to find the hypotenuse. So that will be 1 squared plus 1 squared equals c squared. We have 2 equals c squared, and c equals the square root of 2. So this is going to be our standard triangle for our 45, 45, 90 triangle. And so question 3 says, is it necessary to write all three ratios, like shorter leg to hypotenuse, longer leg to hypotenuse, shorter leg to longer leg? And the answer is no, because when we go back and we look at our original triangle, both legs have a length of 1. So we know that there's not actually even a shorter or longer leg. They're both the same leg. So for instance, so shorter leg, longer leg, we can just say leg to hypotenuse. And we can see that's answered right here. And what is that ratio? The ratio is 1 to square root of 2. And when it asks us about shorter, I mean, you can't even say shorter leg to longer leg, right? It just would be leg to leg. I guess you can write leg to leg. That would be a ratio of 1 to 1. So that means that whatever one leg is, the other one will be the same. And if there's a length of 1, you would multiply the hypotenuse by square root of 2. So when you look at E, we're using the angle-angle criterion, and we remember earlier that in order for triangles to be similar, we could use angle-angle to prove that, which we did because it's 45, 45. So they're asking us if we have a triangle, and it's a 45, 45, 90, and the hypotenuse is 20, what is the length of the other two legs? There are two ways to do this. So the first way will be, I think it's more intuitive. So let's just say that this is x and this is x. Since we both know they're the same, we can use Pythagorean theorem. So we can do x squared plus x squared equals 20. And we get 2x squared equals 20, x squared equals 10, x equals the square root of 10. Okay, so that is one way to do it, which is nice because we're comfortable with Pythagorean theorem. So the second way is I'm going to draw our standard triangle we discovered at the beginning. So this is a beautiful triangle, by the way. Thank you. So 1, 1, square root of 2. And now we have this new triangle, which is 45, 45, 90, and this is 20, question mark, question mark. So what you need to remember about these triangles is when you look at the black triangle, we went from square root of 2 to 20. So they're similar triangles, so it means I multiplied the square root of 2 by some number to get 20. And whatever that number I multiplied by square root of 2, I also multiplied 1 by. So what we're going to do is we're going to write the square root of 2 times x equals 20. And this x, I mean, it might be even better to write a question mark. The square root of 2 times what? gives us 20. So we're finding out the scale factor. And to find that out, you just divide by the square root of 2. And we're not allowed to leave a square root on the bottom, so we're going to rationalize it by multiplying by the square root of 2. And you end up with 20 square root of 2 over the square root of 4, which is just 20 square root of 2 over 2, which is 10 square root of 2. So what we multiplied square root of 2 by to get 20 is we multiplied by 10 square root of 2. So that means I need to multiply this by 10 square root of 2 and this by 10 square root of 2. And that's how we get a length of 10 square root of 2.